The cryosphere offers access to preserved organisms that persisted under past environmental conditions. The overall goal of this procedure is to uncover hidden diversity by successfully collecting and removing exogenous material from frozen cores.
This method can help answer valuable historic questions about select time periods by identifying organisms recovered from glacial ice and permafrost. Collecting an aseptic core in the field is challenging given the high probability of contaminant introduction. Therefore, the main advantage of this technique is that contaminant removal occurs in a controlled laboratory setting.
Visual demonstration of this protocol is critical, as the scraping and decontamination steps can be kind of hard to learn. It's really a two-person job, so it requires a lot of patience and teamwork especially.
Demonstrating this procedure will be two support scientists from my laboratory, Karen Foley and Robert Jones.
This protocol requires meticulous cleanliness. Use an oven set to 450 degrees Celsius to bake the following for 4 hours: sterile nucleic acid-free metal racks, glassware, metal forceps, and glass wool. Use a wrap of heavy foil to prevent recontamination. Next, filter sterilize 95% ethanol and ultrapure water using 0.22 micron filters. These liquids must stay at or below 4 degrees Celsius, or they will crack the sample, making it easier to contaminate. Store the ethanol at -20 degrees Celsius and store the water at 4 degrees Celsius.